Good afternoon, class. Here's chapter 3, derivatives, section 3.4, the product and quotient rules. We've already finished the first part, and we're going to continue and finish the second part. Here's part 2. Number 1, for the two rules, I have given you the shorthand notation f g prime is f prime g plus g prime f. F over g prime, we use the same thing with the negative in between, f prime g minus g prime f over g squared. That will help us to memorize it nice and easy. So uh, this is the product of square root of x. Square root of x is x to the power of 1/2 and e to the power of x. We put it in this format so we can use the power rule. We notice it's the product of the two. I'm going to put a raised dot in between, and then I'm going to call this f, and I'm going to call this g. Therefore, we can use the product rule. So we're going to go with f prime according to the power rule, 1/2 x to the power of 1/2 minus 1, which makes it negative 1/2, times g, f prime g, and g is e to the power of x, plus g prime e to the power of x, the derivative is itself, times f, the first function is x to the power of 1/2. I'll put an asterisk next to it. Believe it or not, this is the only calculus step. However, we have to continue with our algebraic techniques to put them together. So this is not the final answer, even though in some instances, Mom, my open math, your digital platform may accept this as the final answer, but you have to continue. So having said that, we know x to the power of 1/2 is square root of x, so replace it. X to the power of minus 1/2, we take it down according to negative exponential rules. You just move them. A to the power minus n is 1 over a to the power of n. 1 over a to the power minus n is a to the power of n. So you move them, you make it positive, and this is what you get. We notice this has a denominator 2 square root of x, so we can create a denominator here. So we're going to multiply and divide by 2 square root of x. Therefore, we have the same denominator as this one. We have the same e to the power of x. So what is the product here? In essence, you really need to notice this is 2x. So what we are looking at is 1 over 2 square root of x times e to the power of x for the first one. Same thing, 1 over 2 square root of x times e to the power of x, and then times 2x, which means this piece is identical, and we can factor it. So if we factor this piece out, this one gives us 1, this one gives us 2x, and the final answer, h prime of x, is 1 over 2 square root of x e to the power of x times 1 plus 2x. This is the final answer, everybody. What about y equals e to the power of x over 1 plus x? We use the quotient rule, and we're going to call it f over g again. If you write f over g, write the equation from the memory. It's very easy to apply and get to the answer. So in this case, we need f prime, which is e to the power of x, times g, which is the denominator 1 plus x, minus g prime, the derivative of the bottom. This is 0, this is 1, so minus 1, times f, the top function is e to the power of x, and you just write the bottom function in a parentheses and square. We're going to distribute, we get e to the power of x plus e to the power of x times x minus e to the power of x. These two cancel each other. And we put the x in front. The final answer, y prime, is x e to the power of x over 1 plus x quantity squared. Again, y equals 1 plus sine x over x plus cosine x. We are going to use the quotient rule. We're going to call it f over g. So we need f prime. The derivative of the 1 is 0, sine is cosine x, the derivative of sine is cosine x. So the derivative of the numerator is simply cosine x times g, the bottom function, x plus cosine x goes here, minus g prime, the derivative of the bottom. X is 1, cosine is negative sine, so the bottom gives us its derivative, 1 minus sine x times the top, which is 1 plus sine x, and just write the bottom in a parentheses and square it. I put the asterisk next to it again, reminding everyone this is the only calculus step, but this is not the finished job. You must continue and finish that in the following manner. This is x cosine x, this is cosine squared. What is this one? A minus b, a plus b, the product is a squared minus b squared, so 1 minus sine squared. Reminding you of Pythagorean identities in trigonometry, sine squared plus cosine squared is 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. So if we look at the first one, it also means sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared, if you look at the very first one. So we are going to replace this with cosine squared. Cosine squared and negative cosine squared cancel each other. The final answer, y prime, is x cosine x over x plus cosine x quantity squared. G of t is t minus square root of t over t to the power of 1/3. Do we have to use a quotient rule? It's important to understand. When you have to use the quotient rule, if you avoid it, you make it normally more difficult. On the other hand, if you don't have to and you use it, that's even worse. And the answer is no, we don't have to use a quotient rule because we are going to use our algebraic techniques first in the following manner. Number one, we make up two fractions. And number two, square root of x is x to the power of 1/2. So square root of t is t to the power of 1/2. So we make up two fractions. This is your algebraic technique. The second technique we're going to use is the quotient rule of exponentials. This has exponent 1. So when you apply the quotient rule of exponential, t to the power of 1 minus 1/3, which is t to the power of 2/3. For the second one, minus t to the power of 1/2 minus 1/3. And I hope you can figure out that this is take a common denominator and becomes 1/6. And now we are going to use the power rule for each case. This one. So if I want G prime, this is 2/3 t to the power of 2/3 minus 1 gives me negative 1/3 minus 1/6 t to the power of 1/6 minus 1 is minus 5/6. And so each one has a negative exponent. And as you can see with the negative exponential rules, just move it and they become positive. So you move this down, t to the power of positive 1/3, you move this down, t to the power of positive 5/6. It's very straightforward, everybody. So we have the derivative of trigonometric functions. What is the derivative of tan x secant squared? Let's look at the proof. So if y equals f of x equals tan x, we know tan x is sine x over cosine x. And I want to remind you of a few trigonometric identities, including reciprocal identities. For example, tan x is sine x over cosine x. It's also 1 over cotangent x. This is the reciprocal identity. Cotangent x is cosine over sine, also 1 over tangent. This is the reciprocal identity, and so are these two. Secant x is 1 over cosine x, cosecant is 1 over sine x. So we are using the fact that this is sine over cosine. Therefore, we're going to write it as f over g and use the quotient rule, f prime g minus g prime f over g squared. I highly recommend you write the formulas that you have in your mind, you have memorized next to the question and apply that. Because again, some students are used to ddx of this, ddx of that, and that's fine, but it takes way too long and sometimes it becomes difficult to follow. So f prime g minus g prime f over g squared. F prime, the derivative of sine is cosine, times g, which is simply cosine x, minus g prime, the derivative of cosine is negative sine, times f, which is sine, and you just put the bottom and square cosine square. Again, I put an asterisk next to it, meaning this is the only calculus step. We're going to continue. We're going to write this as cosine squared plus, okay, negative times negative, plus sine squared. As you know, the sum is 1. And if 1 over cosine is secant, 1 over cosine squared must be secant squared x, and that's the proof. Let's prove that the derivative of secant x is secant x tan x. And so if we let y or f of x be secant x, we can use 1 over cosine x, and therefore we are going to go with the quotient rule. We're going to write it f over g. So f prime g minus g prime f over g squared. So y prime is f prime. The derivative of the numerator is 0 because it's a number, times g, which is cosine x, minus g prime, the derivative of cosine is negative sine x, and times f, which is 1. I just write the denominator squared. This goes to 0. And this is positive sine x. Now, how did we prove identities in trigonometry? we did use proper identities. So we're going to cut this. The algebraic technique is to cut this into two fractions, 1 over cosine, sine over cosine. 1 over cosine is secant x, sine over cosine is tan x. And that's the proof that the derivative of secant x is secant x tan x. Find an equation of a tangent line to the graph of the function y equals x over 2x minus 7 at 3 comma negative 3. To come up with any line, you need a pair, x comma y is given, and also you need the slope. The slope is not given, so you differentiate first. To differentiate this, we notice it requires a quotient rule. We're going to call it f over g. So f prime g minus g prime f over g squared. So y prime is f prime, which is 1, times g, which is 2x minus 7. Minus g prime, the derivative of the bottom is 2 times f, which is x, over g squared. Put this in a parentheses and square it, 2x minus 7 quantity squared. This is, believe it or not, the only calculus step. Everything else we're going to do is elementary algebra. Two x minus 7 minus 2x. 2x and minus 2x cancel each other. So y prime is negative 7 over 2x minus 7 quantity squared. Bear in mind, this is the derivative of the function y or f of x. It is not the slope. The slope at any specific point you have to plug in. In this case, m is y prime evaluated at 3. So replace the x with the x coordinate of the pair, namely 3. 2 times 3, 6 minus 7 is negative 1. When you square that, you get positive 1. So the final answer is minus 7. Y minus y1 equals m times x minus x of 1. So that means y minus negative 3 gives you y plus 3, m minus 7, x minus 3. Distribute minus 7x plus 21. Move number 3, make it negative 3, and y becomes minus 7x plus 18. Bear in mind, this pair belongs to the original function, also to this one. If you plug in 3, you get minus 3, right? That means over here, not anything else. The process is done properly. That's all it means. We want to differentiate where h of m is 9m minus 7 over 5m plus 4. On purpose, I'm using a different variable that normally we use x, maybe t. But the point of this question is when you work on any assignment, including differentiation assignment, You do not change the variable. You stick with the variable that is given to you. So in that case, we notice we have to use the quotient rule. We're going to write it as f over g. We're going to write the differentiation formula for the quotient rule, f prime g minus g prime f over g squared. And we use that shorthand notation. So f prime is simply 9 times g, the bottom function, 5m plus 4, minus g prime, the bottom just gives you 5, over the top function 9m minus 7, and then put the bottom 5m plus 4 and square it. Again, let me put asterisk next to it. I can't emphasize this enough. This is the only calculus step. And this may be, in some cases, acceptable by your digital platform, my Open Math or Mom, but it's not acceptable for the exam. You have to finish the job, you distribute, you get 45m plus 36. You distribute here, you get minus 45m plus 35. 45m minus 45m cancel each other. 36 and 35, they add up to 71. Therefore, h prime of m is 71 over 5m plus 4 quantity squared. This is an acceptable answer as the final answer. Everything must be done, and we have to simplify to get to this answer, everybody. All right. Find an equation of a tangent line to the graph of the following function. Y equals e to the power of x times cosine x at 0, 1. We need two things. We need a pair x comma y is given. We need the slope. We need to find it. And to do so, we have to differentiate. We notice it's the product of e to the power of x and cosine x. I put a raised dot in between, and I call it fg. And we are going to use the product rule, f prime g plus g prime f. So f is e to the power of x, so it's f prime of x times g, which is cosine x, plus g prime, the derivative of cosine is negative sine x times f, which is e to the power of x. And this is the only calculus step, everybody. We're going to factor the e to the power of x out. We get e to the power of x times cosine x minus sine x. And to come up with the slope, this is not the slope, this is the derivative function. M is y prime of 0. So we're going to plug in 0. E to the power of 0, cosine of 0, minus sine of 0. That gives you 1 times 1 minus 0, which is simply 1. And this is the y-intercept with b being 1. So y equals mx plus b becomes m, which is 1 times x plus b, which is 1. And we are done. We want to differentiate y equals 1 minus secant x over tan x. Again, we notice it is f over g, which requires the quotient rule. So we are going to use the quotient rule, everybody. Which means f prime g minus g prime f over g squared. So we want to differentiate the top. 1 gives you 0 minus secant gives you secant x tan x. The derivative of secant x is the product of secant x and tan x. This negative keeps it as negative, times g, the bottom is tan x, minus g prime, the derivative of tan, as you know, is secant squared. So minus secant squared times f, the top function is 1 minus secant x, over g squared. So just write the bottom and square it, tan squared x. Again, I'm going to put the asterisk next to it. This is important to know. This is the only calculus step, everybody. Now, there are a few steps to finish the job, and you must. But the most important step is the calculus step, but it's not a finished job. I can't emphasize this enough. So having said that, minus secant x, the product of these two is tan squared. Now we're going to distribute. We get minus secant squared plus secant cubed. The denominator remains as tan squared. We notice from the top, we're going to write the denominator as it is. From the top, secant x is in common. So we're going to take it out as a common factor. What remains of this one is negative tan squared. This one, negative secant x. This one, secant squared. I'm going to remind you that one of the Pythagorean identities was 1 plus tan squared equals secant squared. Therefore, if I move the tan squared to the right, I get secant squared minus tan squared equals 1. Secant squared minus tan squared. This one and this one. So I'm going to replace it with 1. The final answer, y prime equals secant x, and the bracket simplifies to 1 minus secant x over tan squared. This is the final answer, everybody.